Welcome to calculus. We have high order derivative, that is derivative of n, and then n greater or equal to 1. So those are the values. So let's just go through the calculus problem. We are given that y is equals to 1 plus x to the power negative 1, and then the first derivative will be minus, which is minus 1 plus x to the power negative 2, and then the second derivative will be minus bracket, so we bring down negative 2, and then multiply by 1 plus x to the power negative 3, and that translates to positive 2, 1 plus x to the power negative 3, and then third derivative will give us 2, bring down negative 3, multiply by 1 plus x to the power negative 4, translates to 3 factorial, so that means 3 times 2 times 1, that gives us 6, so 2 times negative 3 is negative 6. So that's negative 3 factorial, 1 plus x to the power negative 4, and then coming to the y to the fourth derivative, so that's going to be negative 3 factorial multiplied by 4, and then that's 1 plus x to the power negative 5, so that translates to positive 4 factorial, and 1 plus x to the power negative 5. And then we can now see the trend and the pattern. So the pattern will give us an idea how the power of n should look like. Now what we do, we have 1 there, that's 1 factorial, and then we have there, that's negative 1 factorial, and then you can see that we have 2 there with 2 factorial when it's second derivative. So then now what we do, we go to the power n will be negative 1 to the power n multiplied by n factorial. Then what else do we know? We also know that negative 1 to the power n translates to alternating signs. So that's it. So alternating starts with a negative and then comes with a positive and so forth. Alternating starting there, and then we have the signs there, 1, 2, 3, 4 factorial. So that will mean that we have 1 plus x to the power negative and negative 1. So that's our pattern. So we're done. That's our equation for n, but we need to prove if that equation is mathematically correct. So math induction is required for that. So you can watch the other video for mathematical induction. So let's let n is equals to k and k greater or equal to 1, and then from there what we do, we have to actually solve for the next one, which is y k plus 1, that power, and then ddx k is going to be ddx. We have negative 1 to the power k, and then deriving that plus 1, so that's going to be k factorial, 1 plus x to the power negative k negative 1. So that's what we have, and now what we do, we have to find the negative 1 to the power k factorial, bring down negative k negative 1, and that will give us 1 plus x to the power negative k negative 2. Okay, so let's see. So that should give us the value of negative 1 k plus 1 k plus 1 factorial, and that will mean 1 plus, so we're taking the original 1 and just adding 1, so it's 1 plus x to the power negative 1 negative k plus 1 negative 1. So it gives exactly the same value, so it's proved to be correct. So our equation is correct, so the nth derivative is correct. So thank you so much for watching, and do not forget to follow, subscribe, and this is your tutor Black Adam 5D tutor Black Adam. So you can leave below comments, any question, I'll come back to you. Don't forget to subscribe. Thank you so much.